What is MANOVA? What is MANCOVA? When should we use these statistical procedures? And what are important assumptions? My name is Fabian Fröse. In this video I will address these questions. How do you actually pronounce these words? That's also open for debate. I say MANOVA and MANCOVA, but I also heard people say MANOVA. But if I hear this, I think MANOVA board, MANOVA 50 or whatever. And I say MANCOVA, but I also hear people say MANCOVA. Yeah, and it sounds like MANCOVA is a cover of a newspaper and the man on it. Okay, yeah, but joke aside, let's talk about what MANOVA or MANCOVA is. It stands for Multivariate Analysis of Variance, MANOVA, or Multivariate Analysis of Covariance. So what is MANOVA? Let me begin by giving you an example. Here we have dogs, cats and horses. So these would be the different groups you would like to compare. And then we would have several outcome variables such as loyalty or number of attacks, and we would like to compare whether loyalty and number of attacks differs between these different animals. Now let me provide you with a definition. You probably know ANOVA. If not, check out my video on ANOVA. ANOVA is a comparison of a mean across different groups. MANOVA is such like an ANOVA, but we have multiple options for outcome variables. And MANOVA allows us to assess the statistical significance of the effect of one or more independent variables on several dependent variables. Like ANOVA, MANOVA has both a one-way and two-way types. So meaning you have one grouping variables or you have two or multiple grouping variables. MANOVA is already a somewhat complex statistical analysis. There are several assumptions that need to be met so that we can fully trust the results of MANOVA analysis. First, in MANOVA there would be two or more dependent variables, and these should be measured at the interval or ratio level or mean values. Second, the independent variables should consist of two or more categorical independent groups. Likewise also the observations, the third point, they should be independent. For MANOVA, because we have so many different groups and different outcome variables, we need a sufficient sample size so that we have enough observations for each of these cases. Then there should be no univariate or multivariate outliers. Another assumption would be normality, so there should be multivariate normality. Then seventh, the relationships between each of the dependent variables for each of the groups should be independent in a somewhat linear relationship. And eighth, there should be no multicollinearity. Yeah, so these are the assumptions that should be met. If there are some violations and you have a very large sample size, the findings probably would still hold. So far I've mainly talked about MANOVA. Things can be more complicated. Yeah? In particular, we would like to consider also confounding variables other than our independent variables. There could be others such as control variables. And if we would like to consider such variables, we would conduct MANCOVA. So multivariate analysis of a covariance and consider covariates. Let me revert back to the previous example. We would like to compare the loyalty and number of accidents of three different animals. Then we can think of other variables that have an influence on the loyalty and number of accidents, such as care or company, if you spend more time with your pet, if you go out and spend time together, that would also have an effect on the loyalty. And that would be important to consider. Otherwise, you might have somewhat wrong results, misleading results, and we would like to avoid that. And MANCOVA allows to consider these different covariates. There are also certain assumptions for MANCOVA. They're fairly similar to the assumptions for MANOVA with a few minor differences. Let me quickly go through it. First, there are two or more dependent variables and these should be measured interval or ratio level. Second, for MANCOVA we look at covariance matrices and these should be equal to reduce type 1 error. Third, independent variable, two or more category should be from independent groups. Fourth, there should be independence of the covariate and treatment effect. Fifth, we would assume there would be some random sampling, that the data was collected using a random selection method. Sixth, so there would be no significant outlier. Seventh, dependent variable should normally distribute for each category of the independent variable. And eighth, homogeneity of variances. If there's some violations, some programs offer alternative test results that are robust to these violations. And as before, if you have very large samples, even then if some assumptions are violated, the results are still fairly robust. Now we come to an end of this video. MANOVA or MANCOVA allows the comparison of multiple groups and multiple outcome variables. It's a very powerful statistical analysis where you can have the simultaneous analysis of many variables in one model. Then of course, if you have more specific questions, you would maybe conduct some post hoc tests or maybe even some UNCOVA and so forth to further understand the difference between groups or outcome variables. MANCOVA, in contrast to MANOVA, can also consider covariates. One of the drawbacks of MANOVA and MANCOVA is you would need fairly large sample sizes so that you can actually conduct the statistical analysis in a meaningful way. I wish you good luck and success with your research projects. Bye bye.